This is for 25.3, and we're going to look at the second half here, number 4 through 7. We're considering a data set here that has to do with top speed recorded of adults versus children on a zip line. So it says consider the next set of data at right, which shows the top speed achieved during each person's zipline ride. Create a back-to-back dot plot. A back-to-back dot plot just means that above the line we're going to make a dot plot of the children's speeds, and below the line we're going to make an upside down dot plot of the adults' speeds. So you're taking each of these numbers and putting a dot above the correct number. So you want to make sure you scale this first. Look for the low and the high so that you know what numbers to include. You can see here that the low is 16 miles per hour and the highest speed is 40 miles per hour right here. So I'm going to go ahead and just show you a completed dot plot so you can compare yours. For now you can kind of just ignore all these other words that are here. On the line we have a low of 16, a high of 40, and this is scaled by ones. And here are the dots for the children, here are the dots for the adults. So let's look at what questions are being asked about the dot plot. Comparatively, how would you describe the measures of center for each group of volunteers? Measure of center is specifically asking for the median. Because we're not looking at symmetric data, the median is a more appropriate measure of the center than the mean. So the median for the children, if you look at the dot plot here, the median is right here. If you count up all the dots, the middle would be right here at 20.5. Versus for the adults, if you count up all the dots, the median ends up being right on this line at 33. So we can see that the median age of the adults is higher than the median age of the children, which makes sense. Or I'm sorry, the median speed for the adults is higher than the median speed for the children. Okay, which is less than the median, we'll say miles per hour. Less than the median for the adults, which is 33 miles per hour. Now, comparatively, how would you describe the spread of the data for each group of volunteers? Spread refers to the range, or the high minus the low. So if we look at the children, if we look at the spread, the highest value here was 30 minus the lowest, which was 16. So the spread is 14. Or we'll say range is 14. Versus the adults, the low was 28 miles per hour, the high was 48 miles per hour. So subtracting those, the spread is 12. So the spread for the adults is less than that for the children. So this is 12. So we can conclude here that the children have a larger range or spread than the adults do. The company claims that heavier people will travel faster down the zip line. Is this claim supported by the data? So we know that adults weigh more than children, and here we can also see that the median speed for the adults is also greater than for the children. So here we could say yes. We know that the adults weigh more. And we know based on our answer to number 5 that they also traveled faster. The last question, does this claim apply to the general population or just to this group? We need to go back to the original problem to check whether or not the data was collected by selecting people randomly from the population or whether it was a non-random selection of people. So going back all the way up to the top, local company has been hired to run a zip line through Griffith Park in LA. A temporary zip line has been installed so that the company can test to ensure its safety. The company has recruited a group of 50 volunteers. That's the key word here. They recruited volunteers. They didn't randomly select people from the population. So in this case, this is only applied to the group. And the reason is because they selected volunteers. They did not randomly select people. Oops.